next part on Introduction to Digital Electronics is the number systems. Okay, so this is what we're all familiar with, right? We know since kindergarten that we can count from 0 all the way to 10 and so on and so forth. You can, whatever number you know, right? This is the ones place, this is the tens place, and if I have a number 3424, for example, I know this is the ones, the tens, the hundreds, and the thousands place, right? So you're very familiar with the decimal system. Now, in order for the computers to work in digital systems, you need to know something called a binary and a BCD. Okay, BCD stands for binary coded decimal. All right, so I'm going to teach you how to convert from decimal to binary and decimal to BCD and vice versa. So let's say I have a decimal that is number 4. Okay, binary, what I'm going to do is that I'm going to count in bits. Okay, bits are zeros and ones, and bits, 4 bits make a byte. So I'm going to count in 4 bits, which make 1 byte. Okay, if you are wondering what the hell am I talking about, it doesn't matter. All you need to know is that I'm going to have 4 bits. So the most left one is my most significant bit, and my right one is my least significant bit. Okay, so I'm going to write bit, 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 bit. So each of these bits can be zeros or ones. Okay, and all you need to know is remember these 4 numbers: 8, 4, 2, 1. Okay, you think you can remember 8, 4, 2, 1? Now these 4 numbers are going to help you convert decimal to binary and vice versa. So if my decimal is a 4, a value 4, the binary equivalent, if I look at 8421, is that I want to see which of these 8421 will give me a value 4. So I know it's only this value, only a value 4. So this 821 I do not want. So if I do not want them, I put as a 0. 4 I do want. 2 I do not want. And this one I do not want, so I put a 0. Okay, so it's 0, 1, 0, 0. Okay, so this is the binary equivalent of a decimal. So let's do one more as an example. So let's say I want 11. Okay, and I want you to work out what the binary equivalent is. So I'm going to write same in 4 bits, right? So to make up 11, I probably, let me erase the 4 way here. So to make up 11, I want 8, I want 2, and I want 1. So 8 plus 2 is 10, 10 plus 1 is 11. So yes, it gives me 11. So I do not want the 4 now. So to get 11, I want the 8, I don't want the 4, I want the 2, and I want the 1. Okay, so this is my binary equivalent to decimal. So let's say the question asks you to calculate backwards from binary to decimal. So from binary to decimal, let's say I give you a 1101, for example. Okay, just a random 4-bit number. So if you work backwards, I want the 1, I do not want the 2, I want the 4, I want the 8. So 8 plus 4 is 12, 12 plus 1 is 13. Remember, this one, I do not want the 2. So 8 plus 4 is 12, 12 plus 1 is 13. So therefore, the decimal equivalent is 13. So that's how you work it with decimal to binary and binary to decimal. Now, if you're wondering, wait a minute, so what if I have 1, 1, 1, 1? It is possible, it's very possible. What this means is that the decimal equivalent is 8 plus 4 plus 2 plus 1, which is 12 plus 2 is 14, 14 plus 2 is 15. Right? So I have 15. Now, what if I want the number 17, for example? What if I want the number 17? Does this mean I can't form 17 with a binary? No, I can, because what I need to do right now is that I now need to consider, let me give myself some space here. Instead of 8421, so let me do a different number so you know it's differentiated. So instead of 8421, you notice the pattern is that 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, 64 times 2 is 128. So again, I'm working in 4 bits. And if I want, remember we were talking about 15, and then what happens if you go to 17, for example, right? What is the binary equivalent for 17? It's not drawing. Okay, finally, 17. I can still form 17 using these numbers. So for 17, I want the 16 plus 1. 16 plus 1 will give me 17. So I do want the 1. I want the 1. I don't want the 2, so 0. I don't want the 4. I don't want the 8. I want the 16, right? I want the 16. I don't want the 32, I don't want the 64, and I don't want the 128. Yeah? So the binary equivalent of 17 is 0001, 0001. Okay? Can? Now I go on to BCD. So with the BCD, what I'm going to do is I'm going to take each individual decimal, and write out its individual binary. What do I mean by that? So the decimal for binary is 0100. So the BCD is also for 0100. Now, but once I go on to 2-digit decimal numbers, it starts to change. Yeah. So 11, I need to take each number 1 individually. So a 1 binary is 0001. So this is the first one. The second one is also another 0001. So each decimal number will have its own 4-bit binary equivalent. Okay, so you're still confused. Let's do 13. So 13, I'm going to take individual decimal numbers. 1 is a 0001. This is my 1. And 3, the 13, the 3 is 0011. So this is the 3. So if I place them side by side, the 13 is actually, the BCD is 0001 to represent the 1, 0011 to represent the 3. 15 is 0001, okay, and to represent, so that's the 1. To represent the 5, I need to have 0101. So this represents the 1, this represents the 5. What if I have a number 36, for example? So a 3 is 0011. Okay, this is the 3. And the 6, remember to make 6, I add 4 plus 2, yeah? So it's 0110. So this is my 6. Okay? So this is how you jump between decimal to binary to BCD. You just have to know these numbers 8421, right? Sorry, I think I placed the comma at the wrong place. It should be 4-bit, 4-bit, yeah? Yeah, so one last thing I need to tell you is that to kind of tell the people looking at your numbers what sort of a decimal, binary, or BCD you're representing, you have to put these subscript numbers here. So decimal is 10, base 10. Binary is base 2. BCD is base BCD. Okay? So, like, how do I know whether this 0100 is a binary or 0100 is a BCD? You need to look at the base. So every time you write decimal numbers, you have to write base 10, base 10, base 10, base 10, base 10. Every time you write binary numbers, you have to write base 2, base 2, base 2, base 2. Every time you write BCD numbers, you have to write base BCD, base BCD, base BCD, base BCD. Okay, so these are the information you need to know about the numbers decimal, binary, BCD. Know how to convert between decimal to binary, binary to decimal, decimal to BCD, BCD to decimal, and so on and so forth. Okay, so that's it. And then the third part of this video, which I'll show you in the next part, is talking about the 7-segment BCD display. Okay, so see you in video 3.